So we're going to split this between 2 days when it comes to factoring. So we're on to P.5a. We're going to do some factoring of some polynomials. And then today we're just really going to look at like trying to find like the greatest common factors out of polynomials, and then we're going to do some factoring by grouping, and then tomorrow we'll get into like factoring our trinomials, you know, which is kind of like using that area model or the FOIL method, that kind of stuff. Sound good? Alrighty. So if I gave you guys, let's say 5x, and then in parentheses 2x plus 3. Do you guys know how to expand that out? We worked on this last section, right? We're going to use like that distributive property, or you could use the area model, right, to multiply those out. So then what do we get? Like 10x squared plus 15x, right? So when we want to factor polynomials, or we want to pull those factors out, we're really just working in the reverse order. So this is like what they're going to give us, and we want it to get back to this form. So I just go piece by piece. I go real numbers to real numbers and like variables to variables. So if I wanted to take this in the reverse order, I'm going to look at 10 and I'm going to look at 15, and I'm going to ask myself, what's the biggest number that divides into 10 and 15 evenly? And my mind tells me it's going to be 5. I thought that's what my... And then I'm going to look at my variables. So I got x squared and x, and I'm like, so what's the biggest x that's going to divide into both of those evenly? X. Right. So that's my factor that I'm pulling out. So now I got to figure out what I got to multiply that by in order to get back to where I was. So if I was at 5, or I'm at 5, and I want to get to 10, I got to multiply by 2. And I'm at x, but I need to get x squared, so I need to multiply by a x. I got a plus, so I'm just going to bring that plus over. I'm at 5, but I need to get to 15, so I got to multiply by 3. I'm at x, and I need to get to x, so I don't need to multiply by anything else, right? Because I already got my little 3 there. Then I can close my parentheses. And I'm right back where I started from. Not too bad. Alright, so let's try one more. So let's say we had, we'll start over here. 18x to the third plus 27x squared. So I want to find the greatest common factor that goes into these. So I'm going to start with my numbers. So with 18 and 27, what divides evenly into both of those? 9. Yep, good job. And if I got x squared and x to the third, I'm going to pull out how many x's? Yeah, I'm going to pull out x squared. Right. What am I going to multiply 9 by? 2. I'm going to multiply x squared by x. Right. I'm going to keep those babies positive. Right. What am I going to multiply 9 by to get to 27? 3. And x squared and x squared, those babies match up, so I don't need to go any further. Not too shabby? So let's spice it up a little bit. Let's say they gave us, so we're going to factor out that greatest common factor between 9x squared times 2x plus 9x squared times 3. So in my little polynomial, because here's my little plus sign, so I'm looking for between this little guy and this little guy, like what it has in common, to find out that greatest common factor that I can pull out. Do you see anything that they have in common? 9x squared, yep. So I can pull that 9x squared out of everything, right? So I got 9x squared, but I want to get to 9x squared times 2x. So what do I got to multiply by? My 2x. Okay. Feeling positive today. I think all my problems have positives in them. That's crazy. So I'm at 9x squared. Oops. But I want to get to 9x squared times 3. So what do I got to multiply 9x squared by? No. Alright, we're back. Sorry about that. Alright. So where are we at? We got 9x squared. And we want to get 9x squared times 3, so we need to multiply by 3. You guys confused on that one? Yes. Not too bad. We could get fancy on it. If we had, let's say, x squared times x plus 3 plus 5 times x plus 3. Extra credit, who can find the common or the common factor, the greatest common factor? X plus 3? I think that's what I heard. Yeah. So x plus 3 is my common factor. So now I just got to figure out what I'm left with, right? What do you think? X squared plus 5? We good on those ones? Coming back to you. Alrighty. So now let's get fancy. We spiced it up, so now it's some fancy time. So we're going to do this thing called factoring by grouping, or factor by grouping. And I know right now with COVID we can't group, can't be in groups, but we're going to do it with factors. So if we put things into group, we're putting them together somehow, right? So let's say we had this crazy polynomial of x to the third plus 4x squared plus 3x plus 12. So we're not a quadratic, so we can't even think about trying to use the quadratic formula. So we can try and pull out a greatest common factor, because that's what you should always start with, is seeing if there's a greatest common factor. So when I look up here, is there a greatest common factor that I can pull out? Nope, there's not, right? They don't have anything in common in all four of those terms. So when I factor by grouping, grouping is putting two or more of these little guys together. And you're looking, so like I could put these two together, and I could put these two together. I could try and put these two together, and I could try and put like these two together, right? What you don't want to do is you don't want to put these three together, because if you put these three together, this little guy over here, is one a group? No, one is not a group. One is the loneliest number, right? So when it comes to factoring by grouping, like even though I could put these three together because they all have an x in common, I'm leaving this guy all alone, and we don't want to leave anybody alone, right? So when we're working on these, we're trying to put them, I mean, if there's four of them, we're putting them in groups of two. So it's kind of a personal preference on how you want to put these together. We're going to hope this keeps going. But you're looking for common factors. So if I put these two together, they're going to have what in common? X squared. Yep. If I put these two together, they're going to have what in common? 3, right? But I could put this guy and this guy together, because what do they have in common? They got an x in common. And I could put these two together, because what do they have in common? 4, right? So you're just looking for, when you put them in groups, you want them to have something in common. So you just want to do first two, last two for first time around. So let's group it with these two together and these two together. And then now I'm going to go right back to where I was, where I'm going to try and pull out that greatest common factor. So between these two, we said they had an x squared in common, right? So we got an x squared. And then what do we have to multiply by? X plus 4. Everybody good with the x plus 4? So now we're going to do the same thing with these two guys. What do they have in common? A 3. And if I factor out the 3, I'm left with x plus 4. And when we're factoring by grouping, our goal is to find another factor that they have in common. So now we're right back to what it looked like up here, right? It has the x plus 3 and the x plus 3 in common, or the 9x squared and the 9x squared. So now we have a factor that's in common of x plus 4 and x plus 4. So now we can factor out the x plus 4. And if we factor out x plus 4, what are we left with? What's our other factor going to be? X squared plus 3. And look at that. You just factored a third degree polynomial. Yes? So, when I looked at these guys, right, what's the greatest common factor that I can pull out? X squared, right? And then on this one, what was the greatest common factor I could pull out? The 3. Right? Yeah. Because what do these guys have? Yep, this one now has that x plus 4 in common, so I can factor that out. So I factored out the x plus 4, right? Let's do it this way. Woo! So I factored out x plus 4. So what do I have to multiply by to get back to here? X squared. Yep. And then my plus. And I got x plus 4, but I need 3x plus 4. So what do I have to multiply by? 3. So that's going to give me my 3. Yep. Pretty snazzy. Fancy people have a hard time doing these, and you guys just did one. All right. Try one more. You want me to do the same problem, but like doing the first and the fourth and the second and third, and see that you get the exact same answer? Want me to do it real quick for you? This is crazy. You guys are gonna think I am so smart here in just a second. I'm gonna blow your mind. So instead of doing the first and the second and the third and the fourth, I'm gonna group them. How do you want to group them? Let's go first and third. Right. Oops, I can't do those two. I can do these ones. Right, first and third. There we go. So I'm going to factor out an x. Right. Here, so from here, I'm going to factor out an x, and I have x squared plus 3. Right. From here, oops, I'm going to factor out a 4. And I'm left with x squared plus 3. So then when I look for my common factors, I get x squared plus 3, and I'm left with x plus 4. Look at that. They match. Isn't that crazy? All right. Let's go through one more example, just to make sure you feel comfortable with these. So let's go with x to the third plus 5x squared minus 2x minus 10. We know we love some negative numbers going on. Right. So we got to decide on how we want to group this. You just want to go 1 and 2, 3 and 4? Sure. So let's group them. So if I look at my first little group, what am I going to factor out of those? X squared. And then I'm going to have what? X plus 5. So now I have negative 2x minus 10. So I got to find out a common factor that I want to pull out between negative 2x minus 10. What do you think it's going to be? Negative 2. Yep. So I have negative 2, and I want to get to negative 2x, so I'm going to multiply by x. I'm at negative 2, and I got to get to negative 10, so I'm going to multiply by positive or negative 5? Positive 5? Right? And then double check it. Right? Oops. Negative 2 times a positive 5 is going to give me my negative 10. If this guy was a negative, it would be negative 2 times negative 5, which would have made that positive. Right? Oh my. All right. So, and one thing to check on, because when we're factoring these, when we get to this point, we want to have that factor that's in common. So if that was a negative, these two are not exactly the same, right? If you owe somebody $5 or if they owe you $5, that's two different things, right? So that positive and negative is going to make a difference. So you're always going to double check when you get to this point to sit there and find that factor that they have in common. And if they don't have a factor in common, I mean, there is the option of where it's just not factorable. But most likely for us right now, because that's kind of like what our goal is, we made a boo-boo somewhere. Right? So what do both of these terms have in common? That greatest common factor, x plus 5. And what are we going to be left with? X squared minus 2. Some fancy stuff today, huh? You guys want to try a couple problems on your own? Yes. Yep. Yep. No, let's try it. I don't know, let's try it, right? Right? So we're going to factor out a x, right? And we have what? X squared minus 2. Right? Good so far? So then between 5 and negative 10, we're going to pull out a positive 5, so plus 5. And then we'd have x squared. And then 5 times what's going to get us negative 10? Negative 2. Right? What factor do they have in common? Yeah. And what are you left with? X plus 5. And I think they match. Look at you, fancy pants. All right. You guys got any other questions? Try a couple of these, see how you feel. All right. Sounds like a plan.